coming soon. So, Gurobi Optimization was founded in July of 2008. We produced our first product release in May of 2009, so we're 4 years into product. You see there the names of the 3 founders. If you've ever heard of something called Cplex or Cplex Optimization, I was the founder of that company back in 1987, and the other 2 gentlemen, Ed Rothberg and Song Gu, who are co-founders of Gurobi, were also principal developers of that software. Gurobi is really a direct competitor for Cplex, so we've used that knowledge. I've been in this business for 25 years to build up a competitive product. So, what is this product? I can imagine a lot of you don't know much about this. We're an optimization solver engine. We fit into the category of analytics and big data in the sense that we can help you, our solver can help you make decisions based upon having large collections of data and large numbers of alternatives to choose from. Decisions about what's right to do for your business. Some of you may recognize linear and integer programming. Technically, that's what the solver does. It's a linear integer programmer solver. I already said it's a direct competitor for Cplex. If none of that speaks to you, one way you can think of what we do is as an engine, like an engine that you put in a car. Right? Although most of us have cars, we care which engine's in there, but we don't necessarily know a lot about it. We probably don't know how it's connected. But we certainly care about its performance. Right? And every car has to have an engine. And that's kind of the role we play for a lot of business applications. We're the optimization underneath that makes the thing work, that produces the answers. Just a quick look at our business model. I don't want to spend too much time on this slide. Support is the way we distinguish ourselves from our competitors. Support is key for us. We answer your questions quickly, usually within an hour. It's an expert who answers them. We have simple pricing and licensing. You can go on our website and our price list is published there, and a number of different kinds of licenses is about a page worth. The most important thing for us in our space is performance, that we can actually solve your problems. To give you an idea what that means, when I started in this business in 1987, this technology was already about 40 years old and was considered to be pretty mature. But if you compare where we are today with where we were in 1987, if you were given the choice of using Gurobi, say, today on a 1987 computer versus using what was a pretty mature technology in 1987 on today's computer, you would be better off making the choice to use Gurobi on the old computer by about a factor of 30. So this technology has come an enormous distance, and performance is key to that. Here are some of our customers. I looked recently, and 6 of the 10 biggest companies by market cap in the world are customers of Gurobi. What applications does it get used for? We get asked that question all the time. A better question is in a sense, what applications can't it be used for? It is an incredibly horizontal technology. I went back to our sales year 2011 through 2012 and tried to categorize the different application areas that Gurobi had been used in. Not necessarily that easy for us to do, because a lot of our customers don't tell us. They just call us up, they buy a license, they plug the license into their application, and they may want to keep it a secret. They may not want to tell us. But in some cases we do, and in some cases we know more than others. And you see 36 different applications here in pretty diverse areas. What I've done actually is I have one more slide on these applications, and I tried to pick out a few of them and talk in just a little bit more detail about each of them to give you maybe a deeper notion of where this technology can be used and how it's used. I should say in advance, Don't ask me hard questions about these applications because my knowledge is, in some cases, fairly deep. Mostly it's quite thin. So, the first one I've listed here is workforce scheduling, and as that is applied, it usually amounts to you have a workforce, they have skill sets, you have jobs that have to be completed, you have to match them, and you have certain times of day or days of the week that they're going to work. Gurobi is being used in such applications by McDonald's, for example, to schedule. This will be rolled out and completed in the next year or so. All 6,000 of their stores in the Asia Pacific region will be scheduled using this technology. Disneyland Japan, which is, of course, a big workforce in one place, and it's a workforce that's changing constantly. You have people going in and out, and on a given day, you don't want two people showing up at the same place to play Mickey Mouse, for example. It is a complex scheduling problem, and that is solved using Gurobi. Finance, there are a number of finance applications. Typically what you're doing is you're balancing return against risk. Portfolio management applications, Mellon, Bank of New York Mellon is using it in that way. The Brazilian Stock Exchange is using Gurobi in a fundamental way to manage risk in their clearing operations. So their clearing operation is a key part of their business, and an important part of that clearing is to handle traders who are becoming insolvent. What do they do with them? And they're using Gurobi to put together as managed risk solutions for those people who are in that situation. Social networking, you've heard of eHarmony. What we're doing here is preference matching. So eHarmony actually literally uses Gurobi to, for every person, this is about every person in their database, to find the 10 best matches. When they say they can do that, they're using Gurobi to do that. That's an optimization problem with 115 million variables in it. It solves in about 2 hours. And I should tell you, and this is true of all these applications, and it's key to this space, the Gurobi Optimizer is not customized to any of these applications. It's the same optimizer. The people build their business application on top of it with their constraints and their objectives. But the optimizer then more or less just plugs in. Transportation is a key application area, particularly airlines. If you fly on an airplane, virtually everything associated with what they're doing is controlled via optimization in one way or another. The crews, which crews are on there, called crew scheduling. Fleet assignment, which type of machine, which type of airplane is being used. The scheduling of the ground crews. The pricing of the seats that you're sitting in, and the availability of those seats and which classes they're in. All of those things. In our particular case, US Air is using this for crew scheduling, FedEx, and the German railroads. So they have a problem that's really essentially a fleet assignment problem that's very similar to what the airlines have, are using Gurobi to do their fleet assignment. Logistics is a huge area of application. I really won't have much time to go into it in too much detail, but you can do things all the way from what are called network management, where you're literally deciding where to build warehouses, where to shut down warehouses to provide this level of service that you need. So that's a pretty long-term strategic kind of a decision, all the way down to daily distribution planning out of distribution centers, managing your trucks and what you do with your trucks. And Oracle, for example, is using Gurobi in a number of its applications that it sells to end users. Walmart is an end user, in this case of Gurobi, to do this kind of thing on the truck routing side, on the distribution planning. Yield management, pricing of perishable resources. Seats in an airplane, those are perishable. If there's nobody in it, that revenue opportunity is gone for the airline. Rental cars. If you don't rent a car on a given day, you've lost that revenue. The day is gone. Hotel rooms in rooms in a hotel, and in this case in particular, Marriott is using Gurobi to do the pricing of its hotel rooms. And for example, this becomes a very complex problem, and particularly in a place like New York, where there will be 5 or 6 different Marriotts. And you get spill from one to the other, and how do they manage that, and what do they do with the pricing in that situation? And finally, electrical power distribution is, again, one of these cases like the airlines, where virtually every aspect of what they do has an optimization piece in it, from unit commitment to dispatching to pricing. So unit commitment means fundamentally the day before you decide which power generation units are going to be used on the next day. That turns out to be a mixed integer programming problem. All of the ISOs in the United States use this kind of technology. The actual dispatching that occurs on day of operation and the actual spot pricing is determined, in the case of spot pricing, using linear programming. And those linear programs are run literally every 5 minutes throughout the day to determine those prices that are used. In Germany, these are 3 of the top 4 providers of electrical power distribution. They're all using Gurobi. And I would dearly love to have been able to announce another deal that we're very close to having done with one of the, arguably the major ISO in the US to adopt Gurobi as its solution for this suite of problems. Okay, how far am I into my presentation, am I? I have 5 minutes left. There's no way I'll get through all these slides. There's a product overview. These are the standard things that you expect from solvers in this space. Our primary product, or our flagship product, mixed integer programming solver, 90% of our customers are using that. APIs, really our job is to make as many APIs available as possible so that you can use Gurobi through whatever language interface you want. I think we've done a pretty good job of that. Particularly distinguishing is our Python offering, which is quite new in this space, and it provides, we've provided a nice, what we call modeling interface, together with some very nice deployment properties. It's kind of the first time that that's been combined in one API. We have a cloud offering. We're the only solver that does have a cloud offering. Just let me say something about just an example of one of the new things that we've added to the product. It's something called Gurobi Compute Server. It is there to enable client-server applications. Right? So basically the idea is that it allows you to seamlessly solve optimization models on remote computers. So imagine you got an application. You want to deploy it. You want to put it on 100 desktops. Right? You can go ahead and develop that application based on optimization, in this case, forgetting about the fact that you want to use something like this compute server. You develop it to run on a single machine. When you're done, by just using this compute server thing, by just putting a 2-line file on each of the potential client machines, there might be 100 or so of them, you can tell it to, as soon as it comes to the point that it's going to do a computation that's potentially computationally intensive, it will then send that computation off to the Gurobi Compute Server that you have somewhere. And the answer comes back, and it does that in an efficient way, and we've got all the appropriate IT support, queuing and load balancing and the like that goes along with it. And so this allows you to have 100 small computers, laptops, running important applications, which are then connecting to these compute servers to do the hard computations they have to do in a seamless, transparent way that you didn't have to pay attention to when you were developing the application. Our licensing model is such that we charge you only for the compute server, we don't charge you for the clients. You can have as many clients as you want. All right? That's client server. These are some of the IT features of the product. Performance benchmarks, and with this I will end. It's a standard thing to talk about performance benchmarks in this space. Performance is key. I already talked about that a little bit. What this slide tells you is since the first release of Gurobi, the current version of the mixed integer programming solver is on average about 16.4 times faster. And that's actually a scientifically fairly carefully measured number. We have a library of models from our customers on the order of 6,000 such models. We run that library, we compute ratios of solve times and geometric means in a very scientific way, and this is the speed up independent of machines. So that's how you get to this story of 1987 versus now, and this is key to our business model that this improvement continues into the future. So if you embed something like Gurobi use it in your solution, you can count on the fact that your solution is going to automatically just get faster because the product that gets plugged in is getting better. And I think that's really it. I'm out of time anyway. Thank you for your time. And are there any questions?
So on that slide you just showed with the 16.4 times performance, what are you changing and what's the secret sauce going on that's enabling that?
Yeah, this is really a subject that's about a combination of mathematics, computer science, and access to customer data, real customer data. So there have been some real mathematical advances that have helped this subject along. Cutting planes, for anybody who's touched this subject, comes out of a subject called polyhedral combinatorics. It is mathematics, and it has made a big difference. We found new ways to solve large linear systems that exploit sparsity in ways people didn't think about 20 years ago, because they don't give you an advantage if you're solving a problem with 100,000 constraints, but if you've got 1 million, it makes a difference. And so ideas have been developed there. Plus, we just, as I said, we get real data sets and we look at them and we say, here's a characteristic, we're not exploiting it, we exploit it. And the technology gets faster. So there are papers published about a lot of this stuff, but there's a lot of it that isn't in the literature.
Architecturally, have you done anything on FPGAs or anything in microcode or anything like that?
We do very little of that sort of thing. There's one of our key technologies does pay attention to the second level cache and so forth. The so-called barrier or interior point solvers really do get LinPack kind of performance out of the core. The GPAs we've investigated. One of the members of our team, Ed Rothberg, is kind of an expert on. His degree is from Stanford in computer architectures. The GPAs don't work in our space. I could explain why, but it would be nice if they did. Any other questions? We do run in parallel. We do exploit parallelism heavily. Yes?
You have some benchmarking versus like the open source packages with that?
Yeah, there are 3 or 4 open source packages. There are 2 of them. I'll mention specific names. GLPK and LPsolve are out there, which are actually quite terrible. You would find ratios of almost 3, 4, 500 if you compare a solver like Gurobi to those. There is one particularly good open source solver if you only want to solve linear programs, and that's the coin solver. It's actually competitive. I don't think there is any open source MIP solver that is competitive. There's one that's reasonably good that's produced by an institute in Germany, Konrad-Zuse Zentrum, that's called SCIP. So there are some alternatives. Any other questions? Thank you for your time.